Hi everyone. The next topic is normal distribution. So we study what the normal distribution is and also how to use R functions on normal distribution. Okay, so recall that the normal density function is given by this f of x. That is 1 over sigma times square root of 2 pi times exponential of negative x minus mu square over 2 times sigma square. So this is the normal with mean mu and standard deviation sigma. So we denote x follows normal mu sigma square. So this looks complicated, but the fact is that if x follows normal 0, 1, this is called standard normal random variable. F of x is 1 over square root of 2 pi. This is just a constant times exponential of negative x squared over 2. So in short, this function is constant times exponential of negative x squared. And this makes bell-shaped curve centered at 0. And actually, we have property that this inflection point is given by negative sigma and positive sigma if mu is equal to 0. If mu is not, then mu plus minus sigma. And this is the normal density function. And the normal distribution is important because remember that when x1 to xn distribution with some mu, mean mu and standard deviation sigma, and we don't know what the distribution of xi is, but if this is IID, then x bar approaches to normal. Now, to be exact, the x bar minus mu divided by square root of sigma over square root of n, this approaches to normal 0, 1, regardless of the distribution of xi. So this is so-called central limit theorem, and this theorem guarantees that many distribution is distributed as normal. For example, let's think about the stock market return. So daily stock market return is almost normal distribution, especially maybe daily return or monthly return, even annual return. These are almost normally distributed because, for example, the daily return consists of maybe 420 the return in each minute. So the daily return is summation of 420 observations, and those are assumed independent because the stock market is unpredictable. So in such a case, the x bar follows normal distribution approximately. Okay, so this is example of R function. So remember that we have 4 R functions for any distribution. For normal distribution, we have the bell-shaped curve. So you can see the d norm is the height. So this height is d norm function. So d norm of 0, actually default mean is equal to, in default mean is equal to 0 and the standard deviation is equal to 1. So centered at 1 and the standard deviation is 1. So 0 is this value, and this value is about 0.399, so about 0.4. And if we type the d norm of -2 to +2, that is d norm of -2, -1, 0, 1, 2, then we can get the number here, 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 and here. So we have 5 values here, 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 and here. So these numbers are negative, the 0.05, 0.24, 0.4, 0.24, 0.05. if we have 800 numbers, 801 numbers from -4, -3.99 up to 4.00, then if we plot, we can draw very smooth this density curve that is shown here. Actually, I saved this image as a low resolution file, so around here it's not smooth, but actually if you generate in R with the same code, it should be a smoother curve. Here almost both tails are 0. Actually the 0 is almost here, so you can see that as it approaches to maybe 3 or 4, the value of the probability density function is almost 0. And some other examples, the p-norm function. The p-norm function gives probability. P stands for probability. So that means given x, the p-norm is this area. And again, the mean and the standard deviations are 0 and 1. So if 0, it's the center. So area should be 0.5. So we get p-norm of 0 is equal to 0.5. And you can see that if we take 2 here, then -2 and +2 covers 95%, as we studied in Stat 20-10. So these numbers are pretty small, you can imagine. And yeah, the area up to 2 is pretty large. So you have studied that this area 2.5% and this area 2.5%, and the center is 95%. So that means the below 2 we have 2.5 plus 95, so 97.5% we should have, and actually 0.975. And Q norm of 0, Q norm is inverse function of CDF, so the inverse of P. So that means the given 0, the probability is 0. So area is 0. What's the corresponding this threshold? Area is 0. So then, so this number goes to -infinity. So we get -infinity here. So when the threshold is -infinity, the probability that x is less than -infinity is 0. And how about Q norm of 0.5? So that means the area is 0.5. So that means the center. So that should return 0. So Q norm of 0.5 is 0. How about Q norm of 0.975? Area is 0.975. So that means that we have here. So that should be 2. And actually about 1.9599. And the last one, the normal random variable. So we generate a random number from that distribution. So we have x here, and bell curve is like this, and the mostly, so this distribution that makes observations around here. So most observations should be between -2 and +2. Sometimes it exceeds. And actually the 10 random numbers from standard normal distribution, normal with mean 0 and standard deviation 1 is -0.67, -0.53, -0.64, -0.41, +0.18, and so on, 0.09, -1.48, 0.53, -1.8. So these are random numbers. You can just specify the number of observations here. You can also change the mean and the standard deviation. We will see in the next slide. Okay, so this is the random, the functions for normal 0, 2 square. So 2 is standard deviation. So sigma is 2, sigma square is 4. So d norm 0. And mean 0, standard deviation 2. That becomes 0.199. So you can see that the standard deviation is twice as large. So that means, okay, so suppose the standard normal distribution is like this. So this is normal 0, 1. Then how about normal 0, 2 square, normal 0, 4? That is twice as wide, like this. Okay, so this is normal 0, 2 square. So that means, okay, so inflection point for blue one is 1 and -1, but for red one, -2 and 2. So we see standard deviation is 1 here, but for red one, 2. But remember that the density function makes the area of 1. So area between density curve and x-axis is 1. So that means if it's twice as wide, it should be lower. Actually, the height should be half of the original distribution. And remember that for normal 0, 1, standard normal random variable, this is 0.3989, so about 0.4. So this point should be about 0.2, and actually we get 1.994 here. And how about the p norm, the probability of the 2 times 1.96 and the mean 0 standard deviation 2? Then, okay, so this is the same as the p norm of 1.96 and mean 0, standard deviation 1. Since this is twice as wide, if we multiply by 2, probability should be exactly the same. So as seen in the previous slide, that we get 97.5%. And how about the Q norm of 0.975? So area, I mean the left-hand side area is equal to 0.975, and what's the threshold? And that is approximately 1.96 times 2. So actually we get 3.92 approximately. So we can change mean and the standard deviation in these functions. So these are the examples of the R code for normal distribution.